Hello, and welcome to today's videos on Kirchhoff's voltage law and AC circuits. Now, Kirchhoff's voltage law, or KVL, simply states that the sum of all voltage drops and rises in any loop of a circuit is equal to zero. Take this DC circuit for example. The power supply is producing 10 volts, and the first resistor is dropping 4 volts. But what about the next two voltages? A simple application of KVL will yield these two equations, one for each of the loops. And from there, it's easy to see that the two voltages are equal to minus 6 volts. Now the good news is that KVL and DC is pretty much the same as KVL and AC. However, AC voltages can be represented in many different ways. These voltages here, however, can be used exactly the same as a DC voltage, and we can convert between them using these equations. What about KVL with a waveform? It's difficult to add sine waves without it getting very complicated. The first step is to find the RMS voltage from the waveform. Take this example. Here the RMS voltage is 15 volts. We then simply take the phase from the waveform and combine the two to make a polar equation. This is known as the phasor form. And we can convert from a polar representation to rectangular representation for addition and subtraction. This is the equation to convert from polar to rectangular, and these are the equations to convert from rectangular to polar. Let's look at an example. Here, the power supply is represented by this waveform, and the voltage across the capacitor is represented by this waveform. Firstly, we convert to the phasor form. The power supply becomes 20 over root 2 volts at the angle of 45 degrees, and the voltage across the capacitor becomes 10 over root 2 volts in the angle of negative 45 degrees. Then we convert to the rectangular representation for the addition and subtraction required in KVL. The power supply becomes 10 plus J10 volts, and the capacitor's voltage becomes 5 minus J5 volts. Then we can apply KVL, which gives us this equation here. Then we can substitute in the voltages we have previously found. Then it is easy to solve, and we get 5 minus J15 volts. And this is precisely why we use the rectangular, so we can subtract these voltages. Then we simply convert back using the same process but in reverse, and we end up with this answer. That concludes the video. Thank you for watching.